Good morning. I'd like to thank you for your time. Today, we're going to be going over our newest location for the Lean Sandwich Shop project. Again, my name is Mason Segura. There'll be a time for questions at the very end. So if you have any questions, I'd ask you to hold them until the end. So the purpose of our presentation today is just real briefly, we're going to go over, define the problem that we're seeing, kind of the root of why we even felt like we had to do this project to increase efficiency here. We're going to outline the current process that's in place, present some opportunities for improvement, propose some solutions that we can actually act upon those opportunities, and then at the very end, we'll illustrate the benefits that we suspect will arise from doing this implementation. So just to give again, brief background, what we do here, we got a boutique sandwich shop. We specialize in hot custom sandwiches, and we got this new location that all metrics and indications told us that it was going to be a hit. All indications for this location were positive, but for some reason, this new location is just not meeting the expectations that we had. And not only is this location ultimately at risk because of its poor performance, but the risk of damaging our reputation as a company, our brand, other locations, we've got some risk to mitigate there. And the demand for this particular location here that we have of concern, 218,000 sandwiches annually. So as you know, we do these risk assessment matrices where we actually are able to balance the probability of a defect occurring or probability of something happening occurring with the impact that we believe it will be on business. And then we have the difficulty to detect, 1 being low, 5 being high for all 3 categories. And from our own internal way to measure or mitigate risk for ourselves, we find those top 3 being the wrong toppings, the bad or spoiled ingredients, and then as you can see down there, it's cold when delivered. And then conversely here, we use a Pareto analysis, and this is what we were able to find at this particular location, that the main thing our customers were having issue with was that their sandwiches being delivered cold, and that accounted for 36, almost 37% of all customer reported defects with their sandwiches. And then actually you can see the remaining 3 of the top 4 all pertain to our toppings. So it's actually kind of backwards from what we see here is what we believe the most current, or at least the highest priority of issues that we need to face are what we're actually seeing with our customers and our top 3. It's kind of the reverse order. So we're going to use a combination of both the Pareto analysis of what our customers are saying is wrong and our risk assessment matrix, which we know internally is our highest priority to mitigate risk. So that problem, 10% of those 218,000 sandwiches, what we're having, we're actually seeing a defect found in them that's actually causing us to remake those sandwiches. Usually being cold food, as we saw, wrong toppings. So we have some defect waste. Those defective sandwiches are causing us to waste. We also have waiting and motion waste because our order fulfillment process is unacceptable. And we'll go into that a little bit more with the way that the process is carried out currently at this location. And then we have some expired or unusable food, spoiled food, because our inventory waste, and that's because of these scrapped sandwiches, as well as food just being sitting, not being able to be used. And then one of our 3 toaster ovens that we were supposed to be using on a daily basis at this location is not working currently. So our current process here, just kind of shown differently. You can see kind of our flow chart here. We have 364 days a year. We're open, 10-hour days, 12 employees working at the location full time. And then we have 600 daily demand sandwiches, and our throughput per labor hour of TPH being 5, and I'll tell you a little bit more about that, and then tack time of 60. So TPH, labor is our most significant cost constraint that we have. And what we're able to do is we're able to find TPH by doing our daily demand divided by our daily labor. So in this case, that's 600 daily demand sandwiches divided by our labor hours of 120, 12 hours. I'm sorry, 12 employees times 10 hours. And we're able to get that TPH of 5. And that's going to be super important because that's the most impact that we can have with the least amount of effort, is changing the way our process is run to increase that TPH. Tack time, simply put, is you can think of it as the minimum amount of time, the maximum amount of time a certain process can take in order to fulfill our demand. We do that by the total available work time divided by the average customer demand. So we'll revisit those numbers in a second, but here you can see just some graphics showing the current process. I'm gonna let you read those, but more or less I'm going to show a different visual representation where you can see we have areas to improve. So what this is, our work balance table. Again, that same graph on the right side and then this new graph on the left side. What we're seeing is each process being graphed based on process cycle time. And the process cycle time is a combination of task cycle time divided by our number of employees. And that actually shows us our process time. And this is just a visual representation of actually what the process that goes into making a sandwich is. And we're going to revisit this and I'll explain a little bit better. But that green line going around is that takt time. You can already see we have some issues. So there's lots of areas where we can improve. There's no secret there, but my job is to make sure that I show you the lowest hanging fruit where I think we would make the biggest impact and then possibly give you some ideas to move forward in the future. So first and foremost, we want to get a new toaster oven, replace the broken one. That's easy thing to do. A little bit of cost up front, but they're going to make a big difference in the long run. We want to be able to separate our machine time from our manual process time to see the actual true account of labor. We're going to combine some tasks so we're not wasting our employees' time, being more efficient with our process. And we're going to design actually a more efficient layout instead of this one-way conveyor belt. Make sure there's a way to account for any defects of the process and continue to go. And then we're going to come up with a process to improve order accuracy, going back to those top three things. So the new toaster oven, this is the same model that we use, just got to buy a new one. Easy day. Going back to that work balance table I showed you before, and the first thing I wanted to do is that we wanted to separate man from machine. So this is that exact same work balance table actually, but what I was able to do is to separate those 165 hour minutes that we see in task 5 here, toasting. Of that, a huge part of it, 140 seconds of it was actually spent waiting for the toaster oven to work. So by separating man from machine, what we're able to do is to actually see an account of what our actual employee is doing during that time. These green bars represent areas where our task is, yes, shorter than our takt time, which is what we want, but it's so much shorter that we actually have waste. We are not using our time effectively in those tasks. The red being a spot where we are past takt time, call it a bottleneck. In this task, what we're able to see is that we're unsustainable, this current process, because we go over our takt time here. So what we're able to do is to combine some tasks. And so what we did here is we went from 7 to 4, that's total tasks. We also were able to take down employees from 12 to 8. And what we see here, again, with our work balance table, when we graphed our process cycle time, we're able to see that with the change of employees and the combination of tasks, which would change the combined task cycle time, we're actually able to get a much more efficient work day with our employees, with fewer employees. And we actually get that TPH, and again, TPH is the way to measure our most significant cost constraint, that being labor. We're able to get that TPH up to 7.5 from 5. This goes back to our, the previous way that we had our things laid out, just a single cycle conveyor belt kind of style. And with our new employee count in the bottom being 8, what we're able to do is to actually organize these 2 parallel cycles. And the way that we're able to do this is by just going on the left side counterclockwise, the right side, left side, counterclockwise, right side clockwise as you're viewing it, or whichever way. I might be mirroring my screen, I can't remember. Long story short, we're able to be more efficient, and even to the point where we can close down half of the cycles in order to operate at those hours that have way less demand at 4 employees. We're also able to have the 2 cycles utilize 3 ovens. That makes it nice that if there's ever a time where we have multiple sandwiches going in the oven at the same time, a single employee can be in charge of 2. And the nice thing is that we are able to address that hot sandwich, because the same employee that takes the sandwich out of the oven is actually the same one that you can see there in task 4 that will wrap and deliver the sandwich. So that employee will never pass that hot sandwich off to another employee where that sandwich has a chance to get cold. And that's addressing a huge 35% accounting for our defects from our customers. Those other areas we wanted to improve was to improve order accuracy. And we can do this twofold. This can come at a later date because there are some costs associated with this. But again, I want to make sure I give you the lowest hanging fruit possible first. What we're able to do is we can use cash registers like the one you see here on the right, where the customer is actually able to visually inspect the order that the employee puts in, confirm that it's accurate. And in that cash register, we can develop a system, or we can use a system that's already been developed, of where that cash register, once that order is inputted, it's actually able to translate visual data to the actual toppings and bread that wants to be selected. So it's a rough kind of example here. You see that picture on the left where we see our common condiments that are placed in the bins there. We can actually have LED lights indicate on the perimeter of each bin on that particular order, that reference number of that order, of what toppings need to go on there. They actually light up, and only those condiments light up. So the employee just has to look where the lights are and grab what's in that bin. Very effective way to ensure order accuracy. Going back to where I talked about TPH, labor being our most significant cost constraint. You can see by just going from 12 employees to 8 and combining tasks, getting that TPH from 5 to 7.5. Our expected labor expense savings goes from 655 to 436,000, giving us an annual expected labor savings of 218,000 and change. The issue here also, we have that 10% failure rate, which means 10% more sandwiches, which means 10% more labor. And so by using these processes that we put in place to decrease our defect rate from 10% down to 2%, which obviously would give us less labor hours needed to remake sandwiches, we get another savings at 56,000 there. So when you actually go back to our risk assessment matrix, and we actually show the left side of pre-constraints that we put in and post-constraints that we put on the right side, the way we're fixing our issues there, we actually see that we're able to decrease the priority levels of those top 3 significantly, to the point where now we can move on to other processes. Some considerations just to consider though with this analysis is that this analysis is based off an average demand rate per day. As we can see, we have a huge fluctuation in actual patrons that come in during lunch hours as well as the dinner hours. So we need to make sure that if we really want to get the most bang for our buck as far as our labor and process goes, we need to make sure that we do an hourly inspection. Standing by for any questions. Thank you for your time.